All right, moving on to the next page, we've got simplifying expressions using identities. So in example number 3, we consider this expression. Determine the non-permissible values for this expression. Okay, so non-permissible values are going to happen when we are doing square roots of negative values, and there's no square roots here, or when we have zeros in the denominator. So really, we're going to have a non-permissible value when the denominator sine of 2 theta is equal to 0. So that's what we're going to look for. So the sine of 2 theta, if we go and check out on the formula sheet, is equal to 2 times the sine of theta times the cos of theta. So when is that equal to 0? Well, it can happen when this factor is equal to 0 or when this factor is equal to 0. Okay, so just to write that out, this is going to happen when sine of theta is equal to 0, or when the cos of theta is equal to 0. Well, when does that happen? Let's consider our unit circle again, just to remind us how this works. Okay, so let's consider the sine ones first. When is sine of theta is equal to 0? Well, that's the y value, so the y values, I guess, would be here, right? And then again over here, that's when the y values are equal to 0. So this would be at 0, comma, pi, and 2 pi, and 3 pi, and so on forever, right? What about, I'll switch to blue here, what about when is cos of theta equal to 0? So that's the x values. The cos is going to be equal to 0. The x would be here and here. So that would be at pi over 2, and at 3 pi over 2, and at the next around, loop around would be 5 pi over 2, and so on. So when I look at this, the way I filled in every pi over 2, haven't I? So you could write, these things out, or under two expressions, or you can just think of it as a jump of pi over 2. Kind of like the tan has a period of pi, the zeros here repeat every pi over 2. So how would we say this? At the end we could say, well, if theta can be equal to all real values, okay, and I'm going to assume this is a general solution, but theta cannot be equal to all the multiples of pi over 2, where k is an integer. So that would be probably the easiest way of writing it. Specifically, I'm giving a more complete answer. The non-permissible values are the multiples of pi over 2, but here I am in a nice, very math-rich way answering that question. Simplify the expression to one of the three primary trig functions. Okay, so it's a simplify thing. So when I'm looking at the 1 minus cos, the part that bugs me in the numerators is I've got another double identity. So I can already go and say, hey, I've taken a look at the denominator, and we said it's 2 times sine theta times cos theta. But what about this cos? It's 1 minus cos 2 theta. So I'm just going to pop up over here, 1 minus cos 2 theta. All right, I've got a few versions. Look at this. I've got 3 different choices for cos 2 theta, right? And just a reminder, I'm looking at 1 minus cos 2 theta in this question. So 1 minus cos 2 theta, I could insert this cos squared minus sine squared in for the minus cos 2 theta. I could put this one in, or I could put this one in. Of the 3, I'm thinking, hey, I like this one here. Because if I take this 1 minus 2 sine squared theta, I'm moving from 2 terms to, look what happens when I take the brackets off, 1 minus 1. The 1's disappear, and I end up getting a positive 2 sine squared theta, right? So a bit of a trial and error thinking about how it's going to work. If I pick this one, I would get 1 minus, and then this wouldn't cancel out, so I'd be subtracting a negative. I'd end up getting a 2. Okay, so I like this one because I'm going from a statement here of 2 terms. This 1 minus 2 cos theta is 2 terms, and once I pick this of the 3 choices, if I pick the middle one, I end up getting 1. So a little bit of thinking, a little mental thinking steps ahead will save you. So I'll go over here and I'll say, well, if I choose that one, I will get 2 sine squared theta. Okay, I should back up a little bit. Maybe I'll start off with this 1 minus cos 2 theta all over the sine of 2 theta. So that changes into this. And now I think you can see what's going to happen. 2 things are going to cancel out. I'm going to get my 2's cancel out, and I can divide both the top and the bottom by a sine theta. So this will cancel out, and the squared part will cancel out. So what do I end up? I end up with sine theta over cos theta, which is equal to tan theta. I'll say it loud with my nice thick pen. There we go. Exclamation mark. Yay. All right. One more example here we have. If cos is equal to, cos of the first angle, alpha, is equal to negative 4 over 5, where now when I'm looking at this part, right away I like to think, what quadrant am I in? So between pi over 2 and pi, I'm in quadrant number 2. So I'm looking at this and I think quadrant 2. Okay, cos of beta is equal to, and I'll come back to that in a second, but I want to look at this quadrant. It's between pi and 3 pi over 2, so this is going to be equal to quadrant 3. Okay, find the cos of alpha minus beta. Okay, so first of all, I know for sure I'm going to be looking at this alpha minus beta, and I will be expanding this. And alpha minus beta is equal to, just from the formula sheet, cos of alpha times the cos of beta plus the sine of alpha times the sine of beta. Okay, so I know already what the cos of alpha is, right? So if I go, hey, here's the cos of alpha. It's negative 4 over 5. So here where I see cos of alpha, I can put in negative 4 over 5. That part's done. I don't know what this part is. I'm just going to leave that. I'll leave a blank there. Oh, actually, what I do, I know the cos of beta as well. Cos of beta is negative 12 over 3, or 13. Right? Negative 12 over 13 cos beta goes over there. So so what I've done so far is I said, okay, they gave me, here I'll put it in yellow, they gave me what this is. So that's how that substitution happened. And then they also gave me this one. Okay, I'll try to get that covered. Yeah, they gave me this one. So that's how far I got. My problem is how can I figure out what the sine of alpha is and the sine of beta is? Okay, so I think we've done something similar to this, but let me make space for my alpha thinking here and my beta thinking about the beta angle here. So the alpha, if I draw my grid, alpha is in quadrant 2, so I'm going to draw some line off to quadrant number 2. Okay, and now I'm going to draw a triangle where one side is on the x-axis, like this. So remember, always draw this so that one side of the triangle is on the x-axis, not to the y. And now I'm going to have, I think we can recognize a 3, 4, 5 triangle. So remember, cos is adjacent over the hypotenuse. So the adjacent is the 4 and the hypotenuse is 5. And because we're in quadrant number 2, this will actually be a negative 4, won't it? And because we're in quadrant number 2, we recognize it as a 3, 4, 5 triangle, but is this a positive 3 or a negative 3? Quadrant 2, it's going to be a positive 3 because it's going upwards. Okay, sine is positive in quadrant number 2. So the sine of alpha is going to be equal to this 3 over 5. Nice. So we can go over here, we can say sine of alpha is equal to 3 over 5. Okay, moving on to beta. So beta is in quadrant number 3. So quadrant number 3 is down here. Okay, and I draw my triangle again, so it shares, one side of the triangle is with the x-axis. Okay, so I don't draw it this way, I draw it this way. And I know that the cos of beta is negative 12 over 13, so my hypotenuse is 13, and my x value is going to be 12, and because it's in this quadrant, I know it's actually going to be the negative 12, right? And I know that this side is going to be negative as well, okay? Now, some of you out there, if you're wise in the ways of Pythagoras, you might, this first one I think you all got, right? 3 squared plus 4 squared equals 5 squared. We know that one. But what about a squared plus 12 squared equals 13 squared. Some of you may know this one already. So really what we got to do is we have to say, okay, this is 169, this is 144, a squared. So what happens when we subtract 144? I'll do this manually here. We get 25, and that's going to be a squared equals 25, so a is equal to 5. Okay, you might be reaching for your calculator on this, but really this is prime territory for a non-calculator question. So if you encounter a 12, 13 triangle and need to, you can recognize it. 5, 12, 13 is another. So this is one of your good old 5 squared plus 12 squared equals 13 squared ones. So this is going to be 5. Now because it's in quadrant 3, it's a negative 5. So my sign of beta will be equal to negative 5 over 13. So over here, sine negative 12. Oh, sorry, negative 5 over 13. Now when I multiply them out, remember again, numerator times numerator, denominator times denominator, so we get negative 48 over 65. 5 times 13, 65. Now this will be negative, so I'll say subtract. 3 times 5 is 15 over, there we go, over 65. Negative 48 minus, oh, did I make an error somewhere along the way? I think I got it right. Negative 48 minus 15 is negative 50 minus 63 over 65. And there is my answer. Okay. Well, we have, you know what, I will take a break here, and then I'll come back and do example number 5.